Hi everyone. Today, we would like to present our topic for microbiology ENT1243, which focus on microorganisms that cause disease in big mammals. In this presentation, we will discuss a chosen microorganism, the rabies virus. The rabies virus will be elaborated in terms of its characteristic, mode of transmission, and how it affects the body.
Let us introduce ourselves. We are a team of 6. We are Putri, Maya, Ainin, Akila, Hana, and lastly Balkis.
Today our group will be exploring the rabies virus, one of the deadliest viral pathogens affecting large mammals, including cattle, horses, and even humans. We will cover its history, biology, biochemical pathways, real-world case studies in natural resources, and effective prevention strategies.
The rabies virus is a bullet-shaped virus belonging to the Lissa virus genus. It is a neurotropic virus, meaning it specifically targets the nervous system. Rabies affect numerous large mammals such as cattle and horses, and transmission happens almost entirely through infected saliva, typically through bite from rabid animals.
Rabies is one of the oldest known infectious diseases. Historical evidence dates back more than 4,000 years. Ancient Mesopotamian texts describe animals that behave aggressively and transmitted sickness through bite. A major scientific breakthrough occurred in 1885 when Louis Pasteur created the first successful rabies vaccine. Despite medical advancement, rabies continues to threaten wildlife, livestock, and humans, especially in developing regions.
These slides explain the causes and transmissions of rabies, which is caused by the rabies Lissa virus. This disease can lead to aggression, hydrophobia, and fever. Rabies is most commonly transmitted through the saliva of affected animals, usually from bite wound that injects virus-laden saliva deep into the muscles, but less commonly through human saliva. The virus enters the body through broken skin or mucous membranes such as the eyes, nose, and mouth. The chart plot shows that the virus spread through the nervous system to the brain, causing the muscles to weaken and resulting in paralysis. From there, the virus spread to other organs including the salivary glands, which allows further transmission, if untreated. Later, the infection eventually leads to coma and death within 7 to 10 days. Common symptoms include aggression and excessive salivation, often foaming at the mouth due to difficulties to swallowing.
When the rabies virus enters the body, it targets the neuromuscular junction binding to nicotinic acetylcholine receptors. From here, it hijacks the neuron's own transport system, moving through retrograde axonal transport towards the central nervous system. Inside neurons, the virus uses an enzyme called RNA-dependent RNA polymerase to replicate. This interferes with normal neurotransmission, ultimately causing encephalitis and severe neurological dysfunction. A notable case study by Lembo et al. 2010 examined rabies in rural Tanzania, where livestock such as cattle are crucial natural resources for rural communities. The study reveals that wildlife infected domestic dogs, which then transmitted rabies to cattle. This caused major economic losses for farmers. After implementing widespread dog vaccination campaign, spillover to cattle dropped by nearly 19%. This shows how controlling rabies in reservoir animals protect natural resources and livelihoods.
Unfortunately, rabies is almost always fatal once clinical symptoms begin. However, before symptoms appear, it is treatable through post-exposure prophylaxis or PEP. PEP involves immediate wound cleaning, multiple doses of the rabies vaccine, and in some cases, rabies immunoglobulin. This treatment is nearly 100% effective when given promptly. Rabies is nearly 100% preventable. Vaccination is the most important method, especially vaccinating dogs, which are the main source of human and livestock infections. farmers and wildlife officers must also avoid handling wild or sick animals. If someone is bitten, washing the wound immediately with soap and water can significantly reduce the viral load.
In conclusion, the rabies virus is an ancient yet still highly relevant pathogen causing severe disease in large mammals. Understanding its biology, transmission pathways, and prevention strategies is essential for protecting both natural resources and public health. Thank you.